It's your friendly math tutor, Miss C, here to convert general form of a quadratic function to vertex form using the completing the square method. So you are going to see that we have an equation written in general form here. Our goal is to get it written into vertex form. Okay, so what we're going to talk about first is this leading coefficient that's labeled with A. We don't have an A value other than 1 right here. There is a slightly different method when you are completing the square when A is not 1. Please check out my other video for that. So for now, we're going to work only when A is 1. And you're going to notice we are going to try to end up with a binomial that is squared here. That's why we're completing the square. So our first step in doing that is I'm going to divide my equation into two sides. We've got the left side and the right side. The reason we do that is because in math, what we do to one side of an equation, we do to the other to keep it balanced. So first things first, we are going to get our x terms on one side and then our constant terms and everything else on the other. So we've got two x terms. We've got the x squared term and then the 8x term. I'm going to move 13 to the other side by subtracting 13. Y and negative 13 are not like terms, so they stay separate. So I have y minus 13 on this side and x squared plus 8x on this side. This method is called completing the square because we are making a perfect square. And here's how we do that. We take this b term, right, which has a value of 8, and we cut it in half. So we're going to say 8 divided by 8 divided by 2, which is 4. All right. And now this is where we make a perfect square. We are going to square 4. So our next step is to square 4. And when we do that, we get 16. This is our perfect square. So I'm going to write that here. And as a reminder, in math, what we do to one side of an equation, we do to the other. So since I added 16 on this side, I'm going to add 16 on this side. All right, so now I'm going to start combining terms and I'm going to work to get this into this form. So on this side, I have y plus 3 equals. All right, I'm going to start with my parenthesis here. This only works when you have a perfect square. So this is x plus, and this is my perfect square. So the square root of 16 is right here, is 4. Now, what's cool about perfect squares is if I expanded this binomial, right, x plus 4 times quantity x plus 4, this FOILs out to x squared plus 4x, right? So I did that. And then I'm going to say 4x plus 16, and look what happens. I end up with what I started with above. This only works when you have a perfect square trinomial. So that is why we take half of 8 and then we square it to get 16 so we can write it in this form. Our final step is you're going to notice there's a k over in vertex form, so we need to move our constant back over. I'm going to do that by subtracting 3 from both sides. So y equals quantity x plus 4 squared minus 3. You might be wondering, why take the time to convert general form to vertex form? Pretty simple. We can see the vertex really easily. So the vertex of this function, of this parabola, is negative 4 because the vertex is what makes this part 0. So x has to take on the value of negative 4 to 0 that out. And when that happens, y equals 3. So our vertex is negative 4, negative 3. This is a minimum, or the lowest point on our graph, because A right here, as we talked about, is positive 1. It's positive, which means our parabola opens upward. So this is why we use vertex form. Tells us more information about the graph. Thanks for joining me to learn how to complete the square when you have a quadratic function with an a value of 1. Make sure to subscribe for more math videos. Till next time, you've got this.